Let's start the session. Okay. Hello everyone. Welcome. I hope you all are doing good. I'm Sambhav, your senior math teacher, and today we are going to talk about probability. And if you are having any doubt, any problem related to this chapter, you can ask us in the chat box or in the comment section. So I'm just waiting for 2-3 minutes so that everyone can join, and then we are going to start the session. So in the meantime, you can tell me about yourself, from where you are, what are you doing currently, and are you well prepared for the board exams? Are you feeling pressured or not? You can tell me about yourself so that in the meantime everyone can join. Hello sir, hello, yeah, hello, welcome, welcome. Yeah, please do join the session. Please, uh, please be seated there. We are gonna start the session soon. Don't worry. So we are gonna talk about probability. Probability is very interesting topic, no? Right? In ninth class, you may have studied about probability in earlier classes also. But in 9th, 10th, majorly we are talking about two different type of probability, correct? So one is theoretical, one is experimental. So in this class, we are majorly focusing on experimental probability, not sorry, experimental, right? Theoretical probability. So we are gonna assume that every event is as likely is to happen as the other one. If there are suppose 6 events, so the probability of every event is equally likely. Based on this assumption, we are gonna find the probability of different events. Now, I hope everyone did join the session. I'm gonna start the class then. Now, as I told you that we are gonna talk about probability today. So what is that we are going to cover in this session is listed here. First, we are going to talk about the introduction part of probability. Then we are going to see different problems or different scenarios related to coins, dice. Then we have pack of cards, balls, and miscellaneous problems that you can expect in your board exams also. I will also tell you how to avoid common mistakes so that you will not get lesser marks, and then we are going to summarize the chapter. Okay. First thing, the introduction part. Before understanding probability, we should be knowing the different terminologies related to probability. So the different terminologies that we are going to use in this session will be experiment. What is an experiment? Experiment is an operation which can produce some well-defined outcomes. So experiment is something that we are doing to produce some well-defined outcomes. Then what is random experiment? Random means doing something randomly, no? So an experiment whose outcome cannot be predicted with certainty. If you don't know the outcomes certainly, then you can call it a random experiment. Examples would be tossing a coin. Suppose if I'm having this coin in my hand, so there are two faces. Either it will land facing heads up or it will land facing tails up, right? There are only two faces, heads and tail. If I'm tossing it, then what are the chances I will be getting heads or getting tails? Equally likely, no? So there are only two faces, so I got heads only. So probability, you can find the probability of getting heads or tails depending on how many times you are tossing the coin. Then rolling a die, if you ever played any board game such as Ludo, Snakes and Ladders and everything, then you must be rolling a die, correct? So there we have 6 faces. Each one will be marked from 1 to 6, numbers one from 1 to 6, right? So what is the probability of getting this number, that number that we can find? Then drawing a card from a deck. Have you ever played any card game? So if you are having a well shuffled deck, then what is the probability of getting a card? Then picking specific color ball from bag with different balls. Suppose if we are having a bag and if there are some balls of different colors and we are picking up a ball at random from that bag, we don't know what color ball we are gonna get, right? So all these events comes under random experiment. Now we are gonna find the probability of getting heads or tails in a coin or a certain number on a die and something like this. So we are gonna solve different problems related to this chapter depending on different scenarios. so that you can score good marks in your exam. Okay, so should we start? Okay. Now, second one is outcome. The second term is outcome. Suppose if I'm doing some experiment, then after completing the experiment, I will be getting an outcome, no? So, what is outcome? The possible result of a random experiment. Whatever possible results there can be are known as outcome. Like in case of tossing a coin, as I told you, there are two possible outcomes. Either it is gonna land facing heads up, or the coin is gonna land facing tails up, correct? So two possibilities or two outcomes. Then sample space. Sample space is nothing but it is related to outcomes only somehow. So the set of all possible outcomes is known as sample space. So in case of tossing a coin, only two outcomes, heads and tails. So we are gonna write the sample space like this. Rolling a die, these outcomes could be either it can show one face up, 2, 3, 4, 5 and till 6, right? Not more than 6, not lesser than 1. So this is the sample space you can expect when you are rolling a single die. Then there's a tip that we should be always writing the sample space clearly. If you are writing the solution in the exam paper, you should be writing the sample space first, so that examiner will get the idea that you know about the sample space at least. Then only you should be moving on to finding the right solution. Okay, so it is gonna, examiner is gonna give you award with extra marks or full marks if you are writing the sample space clearly. So first thing first, you are gonna write the sample space in the exam. Event. What is an event? A subset of sample space. Maybe I can get 6 outcomes out of a die, correct? Rolling of a die. But suppose if I am only rolling a die twice, thrice, then we cannot get all the 6 outcomes in 3 rolls, right? So how many outcomes we can get? 3, because I am only rolling it thrice. So this is known as the sample subset of a sample space. So if we are rolling a die, then we can expect the outcomes from in between 1 to 6 only, and if we are rolling it thrice, then there will be only 3 outcomes. So rolling a die event would be getting a even number. If we are rolling it once, then what are the chances that we are getting an even number? How many even numbers are there? 2, 4 and 6, 3 only, right? So this will be the subset of the sample space, not out of that set and not lesser than that set, correct? So this is known as the subset of the sample space. Now, types of events. So this is important. Why? First thing first, we need to understand that probability do lie in between a scale. There's a scale known as probability scale. It ranges from 0 to 1. Why only 0 to 1? Because we do understand that either there are only two extreme ends. Either something is impossible to happen or it is inevitable to happen, correct? So if there is something that is impossible to happen, that is known as impossible event, and the probability of that event would be 0. Let me give you one example. What are the chances that tomorrow morning it is gonna snowfall in the Thar desert of Rajasthan? Most likely an impossible event, no? So the probability of happening this event is actually 0. But suppose if I ask you, what is the probability of sun rising tomorrow morning? It is inevitable, no? Sun is rising every day, so it is inevitable to happen. So the probability of sun rising tomorrow morning is 1. So the probability do range in between 1 to 0 to 1, and all the values are in between. Some examples would be the impossible event. For impossible event, getting 7 on a die. If there is no face that is having 7 on a die, then how can we get 7? We cannot get a 7 on a die, correct? For certain events for which the probability is short, getting a number lesser than or equal to 6 when we roll a die. If we are rolling a die, what are the chances we are gonna get a number which is lesser than or equal to 6? 100% chance, because all the numbers are lesser than 6 only. Now, Equally likely events. What are equally likely events? All outcomes have equal chances. When all the outcomes do have equal chances, then we are going to call them equally likely events. So these are some terminologies that you must be knowing. We are going to use them very frequently. Now, important properties of probability. As I told you that probability do range in between 0 to 1 only. So these are very important. So probability can never be a negative value. If someone is telling you that the probability of this event to happen is -1, then of course it cannot be a probability, because probability can never be negative value, and it can't be greater than 1, because the highest probability of any event would be the that it is inevitable to happen, correct? It is gonna happen for sure, and that is the probability of that event would be 1. So the probability of any event can never be greater than 1. So P of E is in between 0 to 1. You can write it like this also, or in this way also, that 0 greater than equal to P of E lesser than equals to 1. So P of E is lying between 0 and 1, including both the values 0 and 1 also. P happening or occurring. So there are two things. Suppose if I'm tossing a coin, suppose if I'm tossing this coin, so there are two things. Either I'm gonna get heads or tails, or in other language I can say that I am not getting heads or tails. So either an event can happen or it cannot happen, correct? So the probability of getting a head or not getting a head is gonna result in 1 always. For an event to happen or occur plus not happening or not occurring, the probability will always result in 1 only. So this you can also show using these two values, P of E. This is usually known as P of E. It means probability of that event. So probability of that event, it is happening. Probability not E, inside bracket you can see not E, no? So probability of that event not to happen, the sum will always result in 1. So this you can write as P of E, and for not E you can use bar over E. So this you can represent using P of E bar is equals to 1. So now they are their sum will always be equal. So that's why they are known as complementary events. One event to happen or that event not to happen, the sum of their probabilities will always be 1. Now we understood the logic behind everything. Now let's talk about theoretical probability. As I told you that there are two types of probability. One is experimental. Suppose if I'm tossing this coin 50 times, and every time I'm tossing I will write down the outcome. This is known as the experimental probability. Suppose out of 50, 30 times I'm getting heads, 20 times I'm getting tails. So the probability of getting heads is what? 30. Total number of times I got heads, out of how many? 50. So 30 by 50, or in a simplified way you can call it 3 by 5. And probability of getting tails is what? 20 by total number of trials that we did, 50. So that is after simplification it is 2 by 5. Now this is known as experimental probability, because we are doing the experiment, then after writing down all the outcomes we are calculating the probability, correct? But suppose if I don't want to do the experiment, there are many things in real world where we cannot go with the experimental probability, such as that ISRO cannot bet on experiments, like they cannot bet on trying to launch a satellite, then checking that is there any problem or not. They will calculate all the possible errors that there will be, and they will then act accordingly, correct? So they will eliminate all the possible errors and everything, then only they will go ahead. They will not take a chance depending on that it will work or not, correct? So there are many things in real life that you cannot uh, bet on by doing experiment. So you should be calculating it theoretically first, then only you can move ahead, right? So same thing we are gonna do in with the probability also. Of course, in some cases you can go with experimental probability, but most of the time you are gonna deal with theoretical probability. So what is theoretical probability? Theoretical probability tells us how likely an event is to happen before we actually do it, before we actually try it. So we are gonna calculate the probability theoretically first, then only we can try the event. So how to calculate theoretical probability then? Is there any formula? Yes, there is. It is based on logic and mathematics, not experiment. So we are gonna apply the logic here. We are gonna assume something that every event is as likely to happen as the other one, and then only we are gonna find the theoretical probability using mathematics. So the formula is P of E, the probability of that event to happen, will always be equals to number of favorable outcomes. Suppose if we want to find the probability of something, then what are the favorable outcomes? So we are going to write the number here divided by the total number of outcomes. Out of total number of outcomes, what is your favorable outcomes? That number divided by the total number of outcomes is your probability. Very easy. You're going to understand this when we are going to see some examples. Let me show you that. Example number one would be a coin is tossed. A coin is tossed once. Now find the probability of getting a head. So if we are tossing a coin, so there are two things. Either it is gonna land up facing heads up, or it is gonna land facing tails up. Correct? So I'm gonna write the sample space first, because we are only tossing a coin once. So the sample space is, oh, the pen is not working. 1 second. Yeah, now. So the sample space here is heads and tails. Correct? So how many total outcomes there can be? 2. And how many favorable outcomes? Only 1, because we need heads. So the probability of getting heads is 1 total number of favorable outcomes by total number of outcomes by 2. So this is the probability of getting heads. Suppose if I'm asking you what is the probability of not getting heads. If you are not getting heads, then what are you getting? You're gonna get tails. So it means not getting heads will always be equals to getting a tails, correct? So what is the probability of not getting heads? It is again 1 by 2. That's why they are complementary. If you add 1 by 2 with 1 by 2, you're gonna end up with 1, correct? Now, one more problem. Two coins are tossed simultaneously. So this time we are tossing 2 coins. Find the probability of getting first part, 2 heads. So first thing first, we need to write down the sample space, correct? Sample space. Suppose if I am tossing 2 coins. So first one is showing me heads. It can show me heads. Second one is also showing me heads. Okay. One event can be. Then first coin is showing me heads, but the other coin is not showing me heads, it is showing me tails. Correct. Third case can be that first one is showing me tails, but this second one is showing me heads. And the last one can be both are showing tails. Both are landing facing tails up. Only 4 possibilities, correct? Now, in the first part, the examiner is asking us that we need to find the probability of getting 2 heads. It means both the coins are showing heads only. How many favorable outcomes are there where both the coins are showing heads? Only 1 outcome. So, probability, first part, probability of this event, I will go with E only for this, is total number of favorable outcomes 1. Out of how many? 1, 2, 3, 4. So, 4. So the probability of getting heads as faced up on both the coins is 1 by 4, because 1 is the favorable number of favorable outcomes and 4 is the total number of outcomes, correct? Then second part, at least 1 head. Now we need to understand this problem very carefully. If it is written at least 1 head, so all the cases where you can see at least 1 head, we are gonna consider them as favorable outcomes. So how many such cases are there? Okay, here I can see one head. Okay, one. Here also I can see one head. Two cases. Here also I can see at least one heads. Both the coins are showing heads only, but at least, so it means it should be at least one. So three possible cases are there, three favorable outcomes are there. In this one, there is no head, so we are not going to consider this one as favorable outcome. So probability of this event to happen is what? 3 total number of favorable outcomes divided by total number of outcomes 4. So the probability of this event to happen is 3 by 4. So just look at the wordings, at least one head. Okay, now next one, dice problem. If you are playing board games, you are gonna use dice, na? So what are different possibilities of probability? A die is thrown once. Okay, we are throwing a die once. Find the probability of getting a prime number. So first thing, as I told you that in your board exam, you are gonna do one thing first. You are gonna write the sample space first. It is gonna give you clarity. It is gonna give the examiner clarity. Okay. So what is the sample space here? How many numbers can there be when you roll a die? How many faces are there? 6 faces, correct? So the numbers are 1, 2, 3, 4, 5, 6. Easy to remember, 1 to 6. Now, in the first part, the examiner is asking us what is the probability of us getting prime number. What are prime numbers? Prime numbers are those numbers which can be divided by, which can have only two factors, 1 and the number itself, correct? So do we have any number here? Yes, 2 is there, 1 is there and 5 is there. So there are 3 such numbers. Is 1 a prime number? No, it is not. Is 1 a composite number? No, it is not. 1 is very unique number, neither composite nor prime. So there are 3 numbers, 2, 3 and 5, right? So what is the total number of favorable outcomes? Probability of this event is number of favorable outcomes, 1, 2, 3. Out of total number of outcomes, 1, 2, 3, 4, 5 and 6. If we can simplify this fraction, we should be doing that. So both are having one common factor, no? 3. So we can simplify this as 1 by 2. So the probability of this event is 1 by 2. Second part, a number less than 3. Okay, whenever it is given as less than 3, so we are not gonna include 3 here. If it is given like less than or equal to 3, then only we can include 3 here. If it is given less than 3, so there are only 2 such numbers, that is 1 and 2. So for second part, the probability of this event is total number of favorable outcomes 2, 1 and 2 out of total 6 outcomes. Again, there is one common factor, that is 2. So we are gonna write it like this. So the probability of this event or the answer to the second part is 1 by 3. The third one is probability of getting odd number. What is the probability of us getting an odd number? How many odd numbers are there? 1, 3 and 5. Correct? The numbers which are not divisible by 2 are odd numbers. So 1, 3 and 5. There are 3 such numbers. So the probability of getting an odd number or this event is total number of favorable outcomes 3 divided by total number of outcomes 6. Again, you can see that we can simplify this further. So we are going to do that. So the answer is 1 by 2. These problems are very easy to solve. You just need to apply the simple logics here. And from this chapter, you can expect 3 to 5 marks problems. So you can easily score in this chapter. Now, second problem based on rolling of a die. A die is thrown once. What is the probability of getting a number that is a multiple of 3? Again, if we are throwing a die once, the sample space will not change. So, should we write the sample space here? I am going to use this space. Sample space is 1, 2, 3, 4, 5, 6. Now, this is our sample space. In the first part, we need to find the multiple of 3. What is the probability of us getting multiple of 3? How many numbers here are multiples of 3? 3 itself and 6, only 2 values. So for the first part, the probability of this event is total number of favorable outcomes 2 divided by total number of outcomes 6. Again, we can simplify this further. So 1 by 3 is our answer. Second part, an even number. So in the last problem, we calculate the probability of getting an odd number. Here we need to calculate the probability of getting an even number. Even numbers 2, 4 and 6. 3 favorable outcomes. And you need to write everything if you want to score good marks. So please in your exam do write everything like total number of favorable outcomes, or first you can go with this favorable outcomes 2, 4 and 6. Total number of favorable outcomes 3. Out of total number of outcomes 6. So the probability of this event P of E will be 3 by 6, that is 1 by 2. So the probability of this event is 1 by 2. Now we are done with two type of problems. One is tossing a coin and the second one is rolling a die. So I will suggest you guys to take a 2-minute break. I will come back in 2 minutes. Then we are gonna continue our discussion on different type of scenarios. Okay. So let's take a break of 2 minutes. Okay, I am back. So we were discussing about probability, right? And we have seen different problems based on tossing a coin, rolling a die. Now let's move on to some other problems that you can expect in your exam. So the second type of problem that you can expect is rolling two dice simultaneously. So if you are rolling two dice, there can be how many outcomes? There can be 36 total outcomes. Why? In this table, we have written down all the outcomes that can there be. First die is showing 1, other die is also showing 1. First die is showing 2, other die is showing, first die is showing 1, other die is showing 2. First one is showing 1, other one is showing 3. 1, 4, 1, 5, 1, 6. And like this, we can create this table. And here in this row, we are having first die is showing 2, the other one is showing 1, 2, 2, 2, 3, 2, 4, and so on till 6, 6, as you can see in the table. So if you are getting a problem related to two die, where you are rolling two die simultaneously, then you can do one thing. You can create this table, and this table is gonna help you for sure. So please don't go blindly with your own judgment that this can happen, this can happen. Do create this table. This will be very helpful. This is very easy to create. Create this type of table. Write 1, 2, 3, 4, 5, 6 here, 1, 2, 3, 4, 5, 6 here. Then wherever you can see the cross section of those two numbers, write them. 1, 1 here, 1, 2 here, 1, 3 here, 1, 4 here, and so on till 6, 6. Now, what is the advantage of creating this table? You are going to understand the advantage of creating this table whenever we are going to deal with the problems. Let me show you some problems. First problem is, what is the probability of getting sum as 8? So it means we are rolling two die and we need to find the probability of getting sum as 8. So sum means that suppose if we are getting 1, 1, then what is the sum? 1 plus 1, 2. Suppose we are getting this outcome, that one die is showing 2, other one is showing 3. Then what is the sum? 2 plus 3, 5. Here we need to find the probability of getting sum as 8. So we are not talking about lesser than 8, greater than 8. We are only saying sum as 8. So sum should be exactly 8. When can sum be 8? Okay, let's see. Till here it is 2 plus 5, that is 7. But look at this outcome, 2, 6. It means first die is showing 2, the other one is showing 6. So what is the probability here, or the sum here? 2 plus 6, 8, exactly. In this line, 3 plus 1, 4, 3 plus 2, 5, 3 plus 3, 6, 7. Again, this value, 3 and 5. Sum is 8. In this row, 4 and 4, 8, 5 and 3, 8, 6 and 2 also 8. Can you see this line? So every outcome in this line is getting sum exactly equals to 8. So how many total outcomes are there? Favorable outcomes then? 1, 2, 3, 4, 5. So favorable outcomes. Favorable outcomes is 5. Total outcomes. What is the total number of outcomes? 6, 6. So 6 into 6, 36. So what is the probability of this event? The probability is 5 by 36. Can we simplify it further? No, we cannot simplify it further because these two values are co-primes. So this is the probability of us getting sum as 8 when we are rolling two die. Okay. So see how easy it is to calculate if you are having the table. Suppose if we are not having the table, then we are gonna count every outcome, correct? So if you are getting problems related to two die, please do create this table. This is gonna save you time. Second part, based on the same type of problem, same type of scenario, that we are rolling two die. Probability of getting doublet. What do we understand by this word doublet? Doublet means that both the die are showing the same number. If first one is showing 1, the other one is also showing 1. If first one is showing 2, the other one is also showing 2. If first one is showing 3, other one is also showing 3, and so on till 6, 6. So how many such outcomes are there? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Is there any other outcome where you can see the doublet? No. So this diagonal, every outcome in this diagonal is showing us the doublet. How many such numbers are there? 1, 2. So I'm gonna write favorable outcomes with FO. Favorable outcomes 6. Out of total outcomes are still same, 36. So what is the probability of this event? It is actually 6 by 36. Is there any common factor? Yes, there is, and that is 6. So we can simplify this one further, and the probability would be 1 by 6. So the answer to this problem is 1 by 6. Again, see the benefit of creating the table, how easily we can calculate the probability, correct? So that's why I'm telling you, please do create the table. Then third, probability of getting sum greater than or equal to 10. Okay, now we need to understand the statement first. Probability of sum greater than or equal to 10. So not only equal to 10, not lesser than 10, it should be greater than or equal to. So sum can be greater than or equal to only. How many such outcomes are there? Okay, let's see. So till here we are having outcome as 3, 6, that is 3 plus 6, 9. If I'm looking at this outcome, this is also 4, 5, the sum is 9 again. But if I'm looking at this outcome, it is 4, 6. 4 plus 6, 10. We can include those outcomes which are having sum exactly equals to 10. So yeah, this one. If I'm looking at this 5, 5, 5 plus 5, 10. 6, 4, 10. So all these values. But we need to include those observations also where we are having sum greater than 10 also. So 6 plus 5 is 11, greater than 10. 5 plus 6 is also 11, greater than 10. And 6 plus 6 is 12, greater than 10. So all the values in this triangle are having sum either 10 or greater than 10. So how many such outcomes? 1, 2, 3, 4, 5, 6. So favorable outcomes. Again 6. Out of total outcomes, 36 only. So probability of this event to happen is 6 by 36, and we can simplify this one further as 1 by 6. So the probability of getting a number, getting values which are gonna sum greater than or equal to 10 is 1 by 6. So this is how you can find using the table. Easy again. It is looking easy because we are having this table. Please do try to solve these problems without using the table, then you will find it very difficult and time consuming. So please do create the table if you are having problems based on 2 die. Now, probability of getting sum greater than 11. Look at the wording. Here they are not mentioning greater than or equal to. They only want to know the probability of getting a number, getting a outcome which is gonna sum greater than 11. How many such outcomes are possible? There's only one, because this is the only number which is gonna result in 12. Both the die are showing 6. 6 plus 6, 12. So this is the only outcome. So favorable outcomes 1. Total outcomes 36. So probability of this event to happen 1 by 36. Already simplified. So what are the chances? What are the odds? You getting 6 on both the die. 1 by 36. Now, probability of getting sum greater than 12. Is that even possible? Because the last outcome that I can see, the highest numbers that I can see on a die is 6, 6, correct? Sum of these two is 6 plus 6, 12. But in the statement itself, it is asking us to find the probability of number, probability of an event which is having sum greater than 12. Is that even possible? No. So how many such favorable outcomes? 0. Total outcomes 36. Probability of this event to happen 0 by 36 or 0 only. So there are 0 chances that you are gonna get values in such a way that their sum is greater than 12, correct? Now, next problem is about cards. So have you ever played any card game? I did, and I do like them, but this time we are gonna play card game in probability only. So in cards, you may have seen that there are different type of cards. There are 2 colors, correct? So you need to remember this. So there are 2 colors only. Either cards are black in color or they are in red color. And here we have four different type of names of them. If you are seeing this type of symbol on a card, then they are known as spades. If this symbol is there, clubs, diamonds and heart. Spade and club are black in color, diamond and heart are red in color. Inside these, we are having one king for each type of card, one queen of each type of card, one jack, one ace, and then we are having a numbered card from 2 to 10. Total number of cards of each type is 10. For spade it is, 13. For spade it is 13 because 2 to 10 and 4 these. So 9 plus 4, 13. 9 plus 4, 13. So every type will be having 13 cards. So how many red cards there will be then? Both are red in color, no? So 13 plus 13, 26. And how many black cards? 13 plus 13, 26 again. So let me give you one important fact about cards. So there will be a total 52 number of cards. Out of these 52, 13 would be hearts, red in color, 13 would be diamond, red in color, spades, 13 black in color, clubs, 13 black in color. Then total number of red card, 26, total number of black cards, 26. How many kings there are? 1 for each type, so 4 because there are 4 type of cards. Queens, 4, 1 of each type. Jacks, 4, aces, 4. Now, these kings, queens and jacks are also known as face cards. So, how many total number of face cards there can be? 12. Then, number of cards are from 2 to 10. The numbered card are from 2 to 10. So, these three are known as face cards. We are not gonna include aces here. So, aces are not included in face cards. So, that's why you need to remember this very carefully, because this is the most confusing part, the face cards. You cannot include aces here. Okay, so only 12 face cards. Problem number 1, based on pack of cards. One card is drawn from a well shuffled deck. Find the probability that the card is a king. Now, if a deck is well shuffled and it is a full deck, then total number of cards is 52. Why I am writing total cards here? Because total cards is also total number of outcomes. Correct? 52. A king. For each type there can be one king. Correct? So there are 4 type of cards. So how many total number of kings? 4. So the favorable outcomes for the first part, favorable outcomes are 4 because there can be 4 kings. Out of 52. So what is the probability of this event to happen? 4 by 52. And you can simplify this one further. It is 1 by 13. So the probability of us getting a king is 1 by 13. A red card. So there are 2 type of cards which are red in color, diamond and hearts. So 13 cards of each type. So total number of red cards is 26, 13 plus 13. So the favorable outcomes in second part is 26. So the probability of this event to happen is 26 by total number of outcomes 52. So that is 1 by 2 after simplification. So the probability is 1 by 2. Third part is not getting a queen. Now, whenever you are seeing problems like this, not getting this, not getting that, this is a case of P of E bar. Remember, E bar means that event is not happening. If that event is not happening, so every other event can happen. Any card can come except queen. How many queens are there? So there are 2 ways to find this. How many queens are there? For third part, there are 2 ways to find this. Queens are 4. So the favorable outcomes would be what? It is 4? No, because we need to calculate the probability of not getting a queen. So we can get other cards. Out of 52, we can not have 4 cards, but other than those 4, we can expect any card. So what is the total number of favorable outcomes? 52 minus 4. That is what? 48. So the favorable number of outcomes 48. Out of total outcomes 52. So the probability of this event, it means not getting a queen, P of E bar is 48 by 52. So can we simplify this one further? Yes, because with 4 we can go at 12 and 13. So this is the probability, 12 by 13. What is the other way of finding this? First, we are gonna do one thing. We are gonna find the probability of getting a queen. How to find the probability of getting a queen? We know total number of queens 4. So the favorable outcomes in that case is 4. You need to mention what is the favorable outcomes here. That we are calculating the probability of getting a queen. So the favorable outcomes 4. Total outcomes 52. So the probability of getting a queen is 4 by 52. That is 1 by 13 again. Now, as we know that P of E plus P of E bar will always result in 1. So we can apply this formula. P of E we are having, P of E bar we need to calculate, and 1 is 1 only. So let me remove everything from here. So P of E we already calculated 1 by 13. The formula is P of E plus P of E bar is equals to 1. We know this 1 by 13 plus P of E bar is should be 1. I'm gonna transpose this to the right hand side. So this is gonna give us P of E bar equals to 1 minus 1 by 13. Take the LCM, subtract the values, and you are gonna end up with 13 minus 1 by 13, that is 12 by 13. So again we are getting the same answer. So there are two ways to find this probability. Either you can find the probability of getting queen first, then subtract that value from 1, or you can find the probability of getting not queen by finding the total number of cards which are not queen. In this case, that is 52 minus 4. So there are two ways. Now, next type of problem. One card is drawn from a well shuffled deck of cards. We need to find the probability that the card is a face card. As I told you that face card are those cards which are either kings, queens or jacks. So 4 of each type, it means 4 kings, 4 queens, 4 jacks. So it means total face cards 12. So this is also favorable outcomes, total number of favorable outcomes, and total outcomes is equals to 52. Then what is the probability of getting a face card is total number of favorable outcomes divided by total number of outcomes, that is 12 by 52. So can we simplify this one further? I guess 6 by 26, and again we can go with 3 by 13. Yeah, so 3 by 13 is the probability of getting a face card. Now the second part is find the probability that the card is not a face card. So we are having the probability of getting a face card, and that is P of E is 3 by 13. As I told you, according to our formula, we can apply this formula, P of E plus P of E bar is equals to 1. Now P of E we know that is 3 by 13. plus P of E bar we need to calculate, and this should be equals to 1. So after transposing this value, we are gonna find P of E bar to be 1 minus 3 by 13. This will be equals to, after taking LCM, 13 minus 3 by 13. That is basically equals to 10 by 13. So this is one way of finding the probability of not getting a face card. What is the other way? Again, the same logic we are going to apply that we have applied in the previous example. If we are not getting a face card, so we can expect any other card, right? So total number of face cards, 12. So then the total number of other cards other than face cards would be 52 minus 12, that is 40. So we can find the probability of not getting a face card by finding the 40 by 52. Again, both are divisible by 4, so 10 by 13. Same answer we are gonna get. There are two ways. Now, third one. In this problem, all kings, queens and aces are removed from a pack of 52 cards. Okay, we are removing all kings, queens and aces from a pack of 52 cards. The remaining cards are well shuffled and then a card is drawn from it. Find the probability that the drawn card is a black face card. Now here the things are gonna get interesting. Why? Because this time the total number of outcomes is not 52. Why? Because we are already removing some cards out of the deck, correct? And how many? It is the number is not directly given to us, but the hint is given that we are removing all the kings, all the queens, all the aces. How many kings are there? 4. How many queens are there? 4. How many aces are there? 4. So total number of cards that we are removing is 4 plus 4 plus 4, 12. Then what is the total number of cards left? Total cards left is equals to 52 minus 12, that is 40. Now we are having a deck of 40 cards only, not 52. Out of these 40s, you need to understand one more thing. Kings are 4, correct? But out of these 4 kings, 2 are red kings, 2 are black kings. Same goes for queens, same goes for aces also. So we are actually removing 6 black cards and 6 red cards. This also you need to keep in mind. Now, find the probability that the drawn card is a black face card. Black face card. How many face cards are there? 12. Why 12? Because it can be king, queen or jacks. But we already removed queen and kings. So only the type of face card that is left in the deck is jacks. So how many jacks are there? 4. But we need to find the probability of getting a black face card. It means it should be a black jack. And how many black jacks are there? Only 2. Correct? Spades and the other one, I forgot the name. So there are only 2 black jacks here. So the total number of favorable outcomes, okay, let me use this space. Total number of favorable outcomes here is 2. And what is the total number of outcomes? 40. Because we already removed these 12, no? So probability of getting a black face card in this scenario is 2 by 40. That is 1 by 20. Next part, a red card. Okay. First thing, we are removing kings, queens and aces, but they are of some color, no? That's why I told you that 6 black cards are removed, 6 red cards are also removed. So how many total red cards left now in the deck? Total number of red cards in the normal deck is 26, half of 52. Half red cards, half black cards. But 6 of them got removed from the deck. So how many we are left with? 26 minus 6. So the favorable number of outcomes in second case is 26 minus 6, 20. And out of 40, total number of outcomes. So the probability of this event to happen is 20 by 40, that is 1 by 2. This is the probability of getting a red card now, because we are already removing the three type of card schemes, queens and aces. So you need to remember one thing: whatever is given in the problem statement, you need to analyze that first, then write down all the possibilities or sample space, then only move further in solving the problem. Otherwise you are going to end up with the wrong answer. Okay, so this is how you can solve this type of problems. Now let's talk about problems based on type of balls, number of balls. In this problem, we must be given a statement like where we must need to choose a ball at random from different colored balls. So there are 6 black, 8 red and 4 blue balls in a bag. Okay, a bag is there which is containing 6 black, 8 red, 4 blue balls. What is the probability of getting a blue ball? Okay, suppose this is the bag. We are having balls at random here in this bag. If you are putting your hand and if you are taking out a ball from this bag, then what are the chances? It can be any colored ball, correct? How to find the probability now? We need to find the probability of getting a blue ball. So first thing, I'm gonna write the total number of outcomes there can be. The total number of outcomes in this type of problems depend on what? Total number of balls, and that is 6 plus 8 plus 4, that is 18, right? So the total number of outcomes that can there be is 18. Out of these 18 outcomes, how many balls are blue in color? 4 only. So the favorable number of outcomes in the first case is 4. So how to find the probability now? So probability of getting a blue ball is total number of favorable outcomes 4 divided by total number of outcomes 18. We can simplify further, so it is 2 by 9. So the probability of getting a blue ball is 2 by 9. Same way you can find the probability of getting a red ball. How? How many total number of red balls are there in the bag? 8 only. So the favorable outcomes, number of favorable outcomes 8, total outcomes 18. So the probability of getting a red ball is 8 by 18, and you can simplify this one further as 4 by 9. So this is your answer. This is how you can find the probability of getting a blue ball, red ball, like this. You just need to write down the favorable outcomes out of total number of outcomes, that is your probability. Now next type is miscellaneous problem. So most of the time you will be getting this type of problem in your exam. The problems that I'm going to show you, the previous problems are just to give you an idea how to find the probability, but this is the main crux now. Now the probability of selecting a rotten apple randomly from a heap of 900 apple is 0.18. And let me tell you one more thing, this problem did appeared in the board exams once. So now we need to find the total number of rotten apples. Here in the problem, they have given us the probability of getting the rotten apple and the total number of apple is given. So we need to find the total number of rotten apples. Okay, we are gonna do one thing. We are gonna apply the same formula, same way, and then we are gonna find our answer. So first thing first, suppose if I'm considering that favorable outcomes, total number of favorable outcomes, or in this case is the getting a rotten apple in the heap is x. Okay, total number of outcomes is what? It is already given, a heap of 900 apples. So total number of outcomes is 900. But along with this, one more thing is given to me, that is probability of this event to happen 0.18. Now I'm gonna keep this value here. I'm gonna remove or I'm gonna replace this with the formula. How to calculate P of E? Total number of favorable outcomes divided by total number of outcomes. So in place of P of E, I'm gonna write favorable outcomes divided by total outcomes 900 is equals to 0.18. I'm gonna transpose 900 to right hand side. So we are gonna end up with x is equals to 900 into 0.18. So 900 into 0.18 is gonna give us 72 and 162. So there are 162 number of rotten apples in that heap. So this is how you can find the total number of rotten apples if it is missing but the probability is given. So you are applying the same formula, you are just finding the different value now. Okay. Second type of problems that you can expect is a box containing 25 cards numbered from 1 to 25. A card is drawn at random from the bag. Find the probability that the number on the drawn card is divisible by 2 or 3, and second part is a prime number. First thing first, we know that the numbers are from 1 to 25, correct? In the first part, we need to find the probability of any number that is divisible by 2 or 3. So I'm gonna do one thing. I'm gonna write the sample space like this, that I'm gonna write all the numbers that are divisible by 2 in between 1 to 25. How many such numbers are there? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and 24. These numbers are divisible by 2. Then I'm gonna write all the numbers that are divisible by 3. So the numbers are 3, 6, 9, 12, 15, 18, 21, 24. In between 1 to 25, these numbers are divisible by 2, these numbers are divisible by 3. So we should do what? We should add all the values, the number of all the values that will be our favorable outcomes. No, it is not. Why? Why it is not the favorable outcomes? See, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers are divisible by 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are divisible by 3. So should we add 12 and 8, 20, and should we divide that by 25? No. Why? Because there are some numbers which are appearing in both the list, no? In 2 also, in 3 also, correct? So we can only include them once, not twice. Otherwise, we are gonna end up with wrong answer. So if we are including all the values that are divisible by 2 and 3 both, so we can keep them here and we can remove them here. So I'm gonna round them. So how to find this quickly? First, you are gonna find the HCF of 2 and 3. So the HCF is 6. So every number that is divisible by 6 or that is a multiple of 6 is nothing but repeated twice in these. So I'm gonna remove them from this list of 3. So that is 6, 12, 18 and 24. All these 4 values are already included here. You can verify also. 6, 12, 18 and 24. So no need to include them again. Now we can find the total number of favorable outcomes. 12 numbers for 2 and here 13, 14, 15 and 16. So there are 16 number of favorable outcomes. So favorable outcomes 16. Total outcomes 25. So the probability of this event is favorable outcomes divided by total number of outcomes 16 by 25. Do we have any common factor? I guess not. We don't have any. So this is how you can find the probability. If you are adding both the list, the numbers in both the list, you will end up with 20 by 25, and then you are gonna write 4 by 5 as your answer. That will be the wrong answer. Second part is that we need to find the probability of getting a prime number. What are the prime numbers in between 1 to 25? Let's make a list. 2, 3, 5, 7, then 11, 13, 17, 19, then 20, 21, 23. These only. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 such numbers. So favorable outcomes for the second part is 9. Total outcomes is 25. Now the probability of getting a prime number P of E is 9 by 25. Is there any common factor? No, there is not. So this is how you can find the probability of getting a prime number. Now let's move on to next problem. What is the probability of choosing a vowel from alphabets? How many vowels are there in English language? A, E, I, O, U. A, E, I, O, U. 5. And how many total alphabets are there? 26. So favorable outcomes 5. Total outcomes 26. Probability of this event to happen 5 by 26. Favorable divided by total. There is no common factor. So this is the final answer, 5 by 26. Correct? So we are only applying the basic logics here. If you can apply the basic logics, then you can easily find the answer. In this problem, 6 faces of die are marked with letters A, B, A, D, A, Q. Correct? So there are 6 faces of a die and they are marked with A, B, A again, then D, A again, then Q. When it is rolled, we need to find the probability of getting letter A. So the total number of favorable outcomes in this case are what? How many A's are there? How many faces can show you A? 3 faces. So the favorable outcomes here is 3. Total outcomes here is 1, 2, 3, 4, 5, 6. So the probability of this event to happen is 3 by 6 or simply 1 by 2. Easy. Second part, probability of getting letter Q. How many favorable outcomes? So there is only one face which is marked with Q. So for second part, favorable outcomes 1. Total outcomes 6. So probability of this event to happen is 1 by 6. Answer. This is how you can find. Then a spinner is marked with numbers 1, 2, 3, 4, 5, 6, 7 and 8 from 1 to 8. Now we need to find the probability of getting a 3. What is the probability of getting a 3? Only one favorable outcome out of total 8 outcomes. So this is your answer. Probability of getting 8, same way. There is only one number. So favorable outcome 1, total outcomes 8, 1 by 8. Probability of getting odd number. What is the probability of us getting odd number? How many odd numbers are there? 1, 2, 3, 4. 4 odd numbers, 4 favorable outcomes by total 8 outcomes. 4 by 8, but we can simplify this further as 1 by 2. So 1 by 2 is the answer. What is the probability of us getting number greater than 2? Not greater than equal to, only greater than 2. How many such numbers are there? 3 to 8. 1, 2, 3, 4, 5, 6. 6. 6 favorable outcomes out of 8. This can be simplified further as 3 by 4. Then number greater than 9. It is not possible because all the numbers are in between 1 to 8. So probability of getting a number greater than 9, 0. Probability of us getting a number lesser than equal to 6. So what is the probability of us getting lesser than equal to 6? How many such numbers? 1, 2, 3, 4, 5, 6. Because we need to include 6 greater than equal to 6, no? So this is 6 by 8, 3 by 4. So this is how you can find easily. This chapter is, you can score in this chapter very easily. Now next problem is, this one is a little bit interesting, because here we need to apply a different logic. What is the probability of getting 53 Sundays on non-leap year? I'm gonna show you a trick here. If this type of problem do appear in the exam, you can apply one trick. How many weeks are there in a year? 52, we know this. So how many days are there in a week? 7. So the total number of days in, according to the multiplication in 52 weeks would be 52 into 7. What is 52 into 7? That is 364. In a non-leap year, total number of days are, total days 365. So there's only one day left, correct? One day. So the probability of us getting a Sunday on that day would be 1. The favorable outcomes 1. Total outcomes are 7. So the probability of having a Sunday on that day is 1 by 7. For any day it is always 1 by 7. If the examiner is asking what is the probability of getting 53 Monday on a non-leap year, you can find in same way. What is the probability of getting 53 Tuesday? Same way. The probability will always remain same, 1 by 7. In case of leap year, this calculation will remain same. So 364, okay. But total days here are 366. One extra day, correct? So then favorable outcomes is either first day can be Sunday or second day can be Sunday, correct? So there can be one for the first case, it would be probability of getting this event is 1 by 7 plus 1 by 7. Either of them can be Sunday, no? So it is 2 by 7. So for any day it is always 2 by 7. Okay. So this is how you can find this. Now, okay. Now we are done with the problems. So now I will tell you how to avoid common mistakes in this chapter, because sometimes we know the answer, we are writing everything, but still we are not getting full marks. Why? What are the common mistakes that we can avoid? First one would be not writing the sample space. If you are not writing the sample space, examiner can think that you are doing cheating in the exam, you are getting the answer from someone else. So please do write the sample space. This is also very much needed for your help only, because I showed you now that sample space can help us, correct? So please do write the sample space first. Counting outcomes incorrectly. You are counting the outcomes incorrectly. Sometimes you can do that. So please, after writing the sample space, you can easily count the outcomes. Then forgetting total outcomes. If you are forgetting total number of outcomes, then you are gonna end up with the wrong answer. So you need to analyze the situation, read out the statement very carefully, then only you can continue. Writing probability greater than 1. As we know that probability can never be greater than 1 or lesser than 0. So if you are getting answer greater than 1, that is not correct answer. If you are getting answer lesser than 0, not correct answer. Okay. So probability should be in between 0 and 1. Now these are the common mistakes that you can avoid. And now let's summarize this chapter. So in this chapter we talked about the introduction part, what is probability, 2 types of probability are there. Then we saw different scenarios based on coin toss, then rolling of a die, pack of cards, balls. Then we have seen some miscellaneous problems also. So we are done with this chapter. If you are having any doubt, any question, you can let us know in the comment section. Till then, goodbye from my side. I will meet you with a next chapter or some other chapter in the next session. Till then, please do take care of yourself.